So the last lesson in P5 is on colours. Before we start, you need to think back to Key Stage 3 and write out a definition for these three words: translucent, transparent, opaque. And once you've done that, have a think about the colours of the rainbow. So that's the visible light part of the electromagnetic spectrum, and you need to know the order of those. So translucent material is one where some of the light is reflected and some of the light is transmitted through the material, the sort of thing you'd find in a bathroom window. Transparent is when most of the light is transmitted through the material, so something like the normal glass you'd see in a window. Opaque objects are ones that reflect light or absorb light. So something which is red would absorb all the other colours of the rainbow apart from the red light, which would be reflected, which is why it appears red. So the colours of the rainbow, and remember, this is part of the electromagnetic spectrum, the visible light part of the electromagnetic spectrum, is red, orange, yellow, green, blue, indigo, violet. And the way to remember that, hopefully you remembered from primary, Richard of York gave battle in vain. And just as a side note, so you remember, the red part of the spectrum is next to infrared on the electromagnetic spectrum, and violet is next to ultraviolet. So why is grass green? So what happens is white light, which is what we see coming from the sun, contains all of the electromagnetic waves of visible light. So all the colours of the rainbow are within white light. When that hits an opaque object, that object will absorb some of those wavelengths and reflect other wavelengths. So in the case of grass, which is green, it will absorb all of the other wavelengths, so all of the other colours, and reflect back green light. And hence our eyes will pick up the green light, and that's why a ball is green. Objects that appear white are ones that reflect all of the wavelengths back at us. So they reflect all the colours of the rainbow, and so they appear white. Black objects are where all of the colours are absorbed, and so it absorbs all of the colours and no light is reflected. And what our eyes see as black is the lack of colour, so the lack of any light being reflected, which of course is why when you wear black in the sun, you get very, very hot, because all of those light waves are being absorbed, and any light wave, all that energy that's been absorbed, will have a heating effect. Now we can use filters in order to change the colour of light. So when white light is coming in, for instance, we've got here a red filter, all the other colours will be absorbed by that red filter, and it will only allow the wavelength of red light to pass through. Now this can have some really strange effects when we look at coloured objects through a filter. So if we take a typical football kit, so we've got red top and blue shorts, and we're going to shine white light through it. So when the white light is shone through, as you would expect, the red t-shirt will reflect red light and the rest will be absorbed. And of course it looks red. The blue shorts, on the other hand, would reflect the blue light and all the other colours would be absorbed, meaning the shorts look blue. Now, if we use filters, this same football kit is going to look very different. So if we start with a red filter, that will absorb all the other colours of light and only allow red light to pass through. That red light is then absorbed or reflected from the football kit. So in the case of the red t-shirt, it would still reflect the red light and of course would appear red. Blue shorts, on the other hand, would not reflect the red light. It would absorb the red light, which means there'd be a lack of colour coming off of the red shorts and they would appear black. Now, if we do the same thing with a blue filter, have a little pause here and see if you can think, what colour would our football kit now go? So hopefully you realise the blue shorts would remain blue because they would reflect the blue light. However, the shirt would now appear black, and that's because it absorbs blue light. It only reflects red light, and as there's no light being reflected, it appears to be black. So if you pause the video now and have a little go at these questions and think about the objects and how they would appear if we used a green filter. So if we only had green light going onto these objects, what would they look like? And then question 2 is just to say, what are the colours that are absorbed by a blue filter? Hopefully there was no cheating going on there. So a green light, the red scarf actually absorbs the green light, and so of course there would be no light reflected, which would make it appear black. A white shirt reflects all of the colours, so because it's only the green light that's been shone and reflected, it would appear green. Black hat, as we know, it appears black because it has absorbed all of the colours, and so it would still appear black. A green ball, on the other hand, reflects green light, and so it would still be green. As for the blue filter, well, the blue filter will absorb all of the other colours of the rainbow. So red, orange, yellow, green, indigo, and violet would all be absorbed because the only one wavelength that's able to pass through is the blue. So that concludes everything we've done this term. Very unusual term on P5, and I will be setting an end of unit test after the half term. But in the meantime, these are all of the things that you need to revise. Make sure you've got the wave equation remembered and that you're able to label a transverse and longitudinal wave. You also need to be able to give an example of how you would measure wave speed using the ripple tank and sound waves in air, and of course in solids as well. You need an understanding of reflection and refraction and those wave diagrams that we did. You also need to understand sound waves and ultrasound. And remember, we're talking there about our sonar. So remember, we're talking about echoes. And the common mistake there is to not do the distance twice because it is an echo. So you need to make sure that when you do your calculations, you use twice the distance. So it's there and back. We then went on to look at the electromagnetic spectrum. And you need to know that order, and you need to know uses of every part of the electromagnetic spectrum. We then looked at lenses, convex and concave lenses, and you need to be able to draw those diagrams and calculate magnification. And of course, then there's this lesson, which is the colours, and this covers all you need to know about colours for the P5. Hope these videos have been helpful.